All right. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. So tonight we're going to pick up where we left off last night, which is finishing up the Terrain LOD stuff. So I've been able to do a little bit of stuff off camera, so we'll go over those updates really quickly, and then we will pick back up. Before we do, though, I just want to give a quick shout out to all of the supporters of the channel, starting with our partners who are the highest tier of subscription over on Patreon and YouTube memberships. They are Gebi Bashir and Gerboles Inc. I'd also like to thank all the other supporters listed here. They are the other tiers of subscription over on Patreon, YouTube memberships, and of course, Twitch subscriptions. So thank you guys very much for your support. I greatly appreciate it. And of course, I appreciate each and every one of you viewers, whether you're here on Twitch or over there on YouTube. We do simulcast to both, and I watch both chats, so thank you guys very much for being here, as well as all of you who have followed this series since its beginning. So, for those of you who may be new here and or have not seen the general introduction, we are working on something called the Kohi Game Engine. So we've got a site here, kohiengine.com, which serves as the portal to the whole project. And basically, this is a game engine built completely from scratch, with the exception of two small header-only libraries. Actually, I think that's three now. But it's all completely written in C and uses Vulkan as its initial backend. I say initial rendering backend because it is eventually going to support Direct3D and Metal at a minimum, maybe OpenGL. Haven't really decided on that yet. But the idea is that the game engine itself is modular, and as such, it supports a series of plugins, and the renderer itself is a plugin. The audio system's a plugin, the UI system's a plugin, and so the consuming application can choose whatever it wants to use. So, a couple important highlights on that. This is 100% free and open source, so it is available freely here on GitHub. It is Apache 2.0 licensed, which means if you want to use this code, all you have to do is say that you're using it, and that is it. There will never be any form of fees for licensing or royalties or any of that stuff. It's 100% free. In addition, all the stuff that we have on the YouTube channel, including the archives of the Twitch stream here, as well as all my other tutorial series and all that stuff, is all 100% free. I don't paywall any of it. So all of the subscription stuff that you see for the Patreon and YouTube memberships, that's basically just a way to say thanks, but it's not required to access any content. I don't paywall anything because I believe education should be free, and that's why we're building this as an educational exercise. So, that is basically the quick 2-minute introduction, right? So with all that out of the way, we will, I guess, jump back into where we left off yesterday. So yesterday we had put in our LODs for terrain in our terrain chunks, and we basically just accomplished that by skipping vertices, right? So I have my terrible looking paint drawing from yesterday that kind of explained how we did that, where this large rectangle out here, or square rather, is representative of the entire terrain. That terrain is split into chunks, so that's these white boxes here. Each chunk is then split down into several levels of detail. And so the level 0 of detail is the full mesh, so that's very small sort of squares. And then each level out from that basically halves the amount of rows and columns. And what we get is the effect of the further out you go on the terrain, the less detail is rendered, right? So it's an optimization for that. And we had most of that correct last night. It was just, there was something that was sort of going through and clobbering the data, and I haven't figured that out on camera. But I did figure out what that issue is. So we'll look at that first. So if we take a look at terrain, the entire issue was this loop here. And so we had something in here that was basically doing j+1, which was not correct. And what we really should have been doing was taking 1 and bit shifting that by j, which will also give us the amount of rows or columns that we need to skip. So obviously it's going to be 0 for the first iteration, and then 2 for the second iteration, and so on, right? And so that gives us everything that we need to actually iterate this correctly. So we've just kind of replaced that with the bit shift operator, using J as our operand for that, right? And so by doing that, we went ahead and fixed the memory issues that we were having there. I also did fix a small issue with our sorting that I found last night. So I'll quickly go over that as well. Thank you guys very much for the follows, by the way. I appreciate that. That definitely helps out for sure. So what we have here is our quick sort, our sort of generic quick sort, right? And the entire issue with this was basically in this section of code here. So this data I was being done up here, actually before this I was incremented, right? And so it was basically just pulling the wrong index. So we needed to move that down here because the only place we use it is here. And it should have been done after this increment. And the other issue is we only actually handle results greater than 0. Otherwise, we just leave them for right now, right? And this is just a quick sort. It's not the quickest sort out there, ironically, with the name. But it's just a quick and simple way for us to be able to generically sort stuff, right? We'll come up with some quicker algorithms as we go. But basically, the caller of this ultimately calls the quicksort function here, passing the type size of the data array itself, what's the minimum index we want to sort at, what's the max index we want to sort at. So this will typically be 0. This will typically be array length -1. And then we pass a compare function. And that compare function can actually deal with the typed data that we need to sort, right? And then it just sort of steps through that. So most of this is the same as it was there. We're just had to fix a couple issues in here. So with all of that said, I'll go ahead and load this up, and we'll talk about the other thing that I added. So load up a scene, right? And if we move around the camera, we can actually see, if you look closely, you can kind of see that terrain popping in the levels of detail in the distance, right? And there are some issues with this that we have to resolve. But it's a little bit difficult, I guess, to see, right? Even if I maximize this, it's a little easier to see what's going on, right? But we've got some cracks in the terrain here, and I'll explain that in a second. But the important thing that I added to this was the ability to visualize the wireframe. And this will really help you understand how the level of detail works. So if we move up a little bit, we can see here that this sort of really dense mesh down here, this is closer to the camera, right? So as we move across the scene, you'll see that more dense mesh popping in. And then we have a level of detail that sort of surrounds that. That's about half of that geometry, right? Or technically a quarter of that geometry. And then if we look a little bit further out, we cut that in half or in quarters again. And then one more time. And then finally a single, essentially quad or 2 triangles for an entire chunk. So by the time you get out to this portion right here, this quad right here that's formed is an entire chunk, right? So this is a chunk, and then this here is a chunk, right? And then this here is a chunk, and so forth, right? So that's kind of what we've been working on. Tsingyi, hello. How are you doing tonight? Good to see you. All right, so with that said, if we switch to lighting only mode here, we can actually visualize a little bit more clearly what one of the problems is. So we see all these sort of holes in the terrain all over the place, these little cracks all over the place, right? And this is where the different levels of detail match up. So if we switch back to wireframe and just kind of focus on one of these, right? Maybe these ones will be a little bit easier. We switch back to wireframe. We can see here that we have a more dense mesh followed by a less dense mesh, right? And that pairing has created this crack, right? Because there's enough geometry in this particular chunk to form a curve here, but this particular chunk is basically averaged it out by just having one, right? And so obviously the further away it goes, the worse this issue gets. It's not quite as obvious when you're right up close to it, but if you look really closely, you can actually see that there are some gaps here close too. So that is what we're going to take a look at correcting tonight. We can see actually here's another example right here, right, of that. Right, so it's most obvious when you're looking at it, and the further back terrain is a little bit higher than the closer terrain. If you have something that's the alternate case, like this guy here or this guy here, it kind of hides it a little bit. But if you were look at it from the other side, you would see this, right? So we just need to handle that. So that is what we are going to look at tonight. So the geometry wireframe visualization, that's simply another mode that we added. So I just added some key bindings for that to switch that over. Did a little bit of work in our rendering backend to support that. So let me just step through that really quickly, actually. So no, it's not the device I want. It's the backend C file that I want. Let me close these, right? And actually I want the diff of that. All right. So what we've essentially done is we have added a new wireframe pipelines to our Vulkan shader, right? And this is something that's internal, right? So we had our pipelines before where we basically have one per topology class. So that's topology class being triangles, lines, or points. And then we have one of those things for wireframe, right? And the reason that we have this versus the other is because when we go to create a pipeline, it's going to be towards the top, if I recall correctly. Let's see. Here we go. We basically have this polygon mode, right? And this polygon mode, if we take a look at that, VK polygon mode, we have the ability to fill, which is sort of the default that we see there when we render geometry, right, where the triangles are filled. We have line mode and we have point mode. And this other one's like an NVIDIA extension to fill quads, but I'm not ever going to support that, right? And so what we support right now are fill and line. I'm not going to support point because, for one thing, Molten VK on macOS doesn't support it, right? And I know that for a fact. So basically, fill is sort of the default that we think of, and then line is what we get when we just want to draw the lines between points, and that's what gives us our wireframe. However, there is no dynamic state available to switch this on the fly unless we have an extension, which isn't always available. And it's not been promoted to Vulkan Core yet, so I'm not going to use that. And so what I've elected to do instead is to create a separate set of pipelines to support that. So all we've done here is we've gone through this file and just said, hey, if the shader is flagged to potentially use a wireframe, and we'll talk about that in a second, then we'll go ahead and check to see if the device supports it, which is basically this Vulkan device features fill mode non-solid, which can optionally be supported by implementations, right? That's why we check that, because not necessarily every implementation is going to support it. So if we don't support it, then we're not going to even try and do it, right? Because we don't want to crash or anything like that. We'll just say that we don't support it. So if the shader is flagged as trying to use a wireframe, but we don't support it, we're going to output a message, and we're going to set that needs wireframe to false. This needs wireframe is used to determine whether or not we create those wireframe pipelines. So we won't create them if they're not supported, basically. That's what that's doing. It's overriding that. So if we come down here, where we're doing our internal pipeline creation here, if we need wireframe, we go ahead and create that array. Otherwise, we don't. Again, we do the same type of creation here for each of our topology classes. We just create the wireframe version of that if we need a wireframe. So we do the same thing here for points, then lines, then triangles, right? The other thing is, if we are supporting if we're supporting wireframe, right? If we need wireframe, then what we do is we actually take the shader flags and we strip out the wireframe flag from that and pass that to the first pipeline config. That's the one that creates our non-wireframe pipeline. Then what we do is we say, okay, well, if needs wireframe, and our creation here was successful, and we've actually created the array, which we should have, then we'll use the same configuration, but we'll add the flags back in, right? And then create that pipeline, right? Which just creates the wireframe pipelines at the same index. And then a little bit further down, oops, let's see. Yep, down here. We also, when we use the shader, we go ahead and we check. Actually, I think this might have just been a, yeah. So what we do is we check to see if the shader is currently set to use wireframe, and if so, we use the wireframe pipelines array. Otherwise, we use the internal pipelines array, right? And then I also just renamed these things a little bit because the shader was named also shader, which is bad because that's like the name of the variable is the same as the type, and that's confusing. So I just renamed that S, and then the one that was called S is now internal, right? So I just kind of renamed that to be consistent with everything else. And then we have a quick query here to check if a shader supports wireframe. So all we do is we pass along the shader, and we say, hey, shader, do you have the wireframe pipelines array? If you do, then we support it, right? Otherwise, we don't, okay? And that's called by the front end to say, hey, can we switch to wireframe mode or not, essentially. So I'll finish up this file, and I see there's a couple questions over there in chat, and I'll answer those in just a second. So the rest of the changes are anywhere where we're using the pipeline layout for like binding descriptor sets. We're just making sure to grab the correct pipeline, and that's what the rest of these changes are, right? We're just grabbing the right pipeline, and I think this one down here is also that. Yep. So that's pretty much the Vulkan renderer aspect of that, right? And then if we take a look at the renderer front end, we just have a single thing here that says render shader set wireframe, enable true or false. And essentially, this function can essentially fail if it's not supported, right? So we call the plugin, we say, hey, renderer plugin, do you support wireframe for this shader? That gives us a yes or a no. If not, we go ahead and warn about it and return false, saying what shader doesn't support wireframe mode so that we can see it in the logs. Otherwise, we go ahead and we flip the flag and return true, right? And then our shader system also has that to pass through. So shader system set wireframe. Basically what this does is if wireframe enable is false, we're always going to support disabling, right? Because you don't have to have wireframe support to disable it, right? You only have to have it to enable it. So if we are disabling it, we go ahead and flip that flag to false and return true as a success. Otherwise, we defer to the renderer, right? Okay, that's more or less some of the updates that I made. All of the view mode stuff kind of builds on top of that and things we've already seen, right? So I'm not going to step into that in detail. All right, so let me have a look at the chat. Let's move this back up here. Okay, this is the biggest question of your life. IAM GUI or Qt for public engines UI? I mean, If I absolutely had to choose between the two, I am GUI. 100%. Because, especially having looked at Qt6. It's a whole lot of nope going on with that. So that's your answer on that one. All right. Good answer, yeah. Is there a way to smooth the transition at the LOD? That is what we're going to talk about tonight. So it's a good question, and we are going to cover that tonight. Do people ever like anti-alias the LOD chunk boundaries? So I think you're more or less talking about the same thing that we're about to cover. Yeah. So obviously we can't have those holes in our terrain, right? And so there's a few ways to fix that. And we're going to take a look at one of those tonight. There's sort of the quick fix for that. And then there's other fixes for it, right? That are more complicated. So we're going to take a look at the simple fix tonight. And we may double back for the complicated fix later, but usually the simple fix is actually pretty good enough. All right. So the issue is, and I'm actually going to go back to Paint for this. So the issue is, if we have, let's see, how do I want to visualize this? If we have one chunk that looks like this, right? And another chunk that looks like this, right, as we saw. Right? This chunk here doesn't have the detail to be able to bend to match this one, right? And so how do we do this, right? There's a couple ways that we could do it. We could try to detect this scenario, right? And add a triangle in here, right? And try and stitch that together. That's one way of doing it. Yarbongos. Thank you for the Yarbongos, Ruche. And so, this is one way that we can handle that. And that's a little bit of a more long-term solution, right? But there's another, a little bit simpler of a way to handle it. And that is, we essentially create around each one of these blocks, right? We create a sort of skirt that drops down all the way around it, right? And so that would look something like this, right? And all we do is we take the geometry information from this edge and we essentially duplicate that and drag it down a little bit along the y-axis. And what that's going to do is, from the perspective that we're looking at here, it's going to fill this in, right? And from a distance, you're not really going to be able to tell the difference. And so that's kind of what we're going to go for right now. The other thing to bear in mind, and I'll run this again just to sort of demonstrate this. So the other, whoops, misclicked there. So the other thing to bear in mind is the split that I have in this terrain is a very linear split, right? So if we take a look at how the geometry sort of falls off, we don't necessarily have to render this high of detail that far out. Like we could either push that out or pull it in, and we need to make that adjustable. This is a very linear transition right now, and really it ought to be on a curve, right? But for right now, we've just sort of linearly applied that. And I don't know if I've reviewed the code for that actually, but basically what we have is we count the number of levels of detail that we have per chunk, and then we essentially take that number and take the ultimate focal length of the camera, or the far clipping plane, and we apply those splits against that full number, and then we do a distance check against each one of these, and we say, okay, if you're this far away, you're this LOD. If you're this far away, you're this LOD, etc. Right? So that's kind of the way that we manage that. Fox Hollow Games, thank you for the follow, by the way. So if we take a look at simple scene, we have a new function here for LODs. And this is basically where we handle the LOD. So it takes in, obviously, a pointer to the scene, the frame data, takes the view position that we are using to determine LOD. So this is the position of the camera, right? We take in the near clipping plane and the far clipping plane of the camera, right? So we pass all this stuff in from the application. And with this information, we could use that eventually for our static meshes as well, but for right now, our terrain. And we say, okay, well, if we have a scene that's loaded, let's loop through each terrain. And for each terrain, we'll go ahead and grab the model matrix, figure out what the range is, right? So how much distance we have between our near and our far clipping plane. And then we create an array of splits, right? Which is essentially ranges of distance. And so we set the first split to 0, right? And this is LOD count plus 1, right? So our first split is 0, meaning right at the camera. And then we loop through that, and we say, well, okay, what's our percentage for this particular LOD given the total LOD count, right? So how far into how far percentage-wise into the total number of LODs that we have is L, which is our iterator, right? And then all we do is we say L plus 1, because we already set 0, is equal to the near clip plus the range, right? So we just bump that out a little bit, times percent. And what that does is that gives us a linear split of ranges for our LODs, right? And so basically we can say, we can then loop through that and determine what LOD to use. So as we go through the chunks, we go ahead and we get the center of that geometry, calculate the distance between the view position and the geometry center here, right? And then we loop through the LOD count and we say, okay, is the distance to chunk greater than or equal to the current split and less than or equal to the next split, which is basically how we check our range. And if it is, that's the LOD that we use. So we set that one and we break. If for some reason we iterate past this whole thing and we haven't found one yet, which likely means that we're beyond the camera, we just go ahead and use the LOD count minus 1 as the LOD, which is the furthest out LOD. And then we set the chunk's current LOD to that. And then when we go to gather the geometry in our query functions, right? All we have to do then is call that chunk current LOD. And the reason that we want to do it this way, and the reason that we don't do it in this function like I was initially thinking, is because this geometry is gathered for more than one thing from different perspectives. So if you recall, our shadow camera has a different perspective than our view camera. And so we don't want to control LOD based on our shadow camera's perspective, because then we'll get all sorts of weird artifacts in the terrain with shadowing, which won't be right, because we'll be using different LODs for those terrain chunks, right? And so we basically, once a frame, we update the LODs for the terrain, and then all we do is query it after that. So there's one query there within query from line, and then there's also another query in terrain render data query, right? And that's how we determine what LOD to use based on the distance from the camera. All right, so we are going to have ads here in just a second, but I am going to catch up on chat as much as I can before the ads pop up. You're welcome. This is wild stuff. Thank you for sharing your progress. Awesome. I'm glad you appreciate it. Yeah, it's come a long way, right? Smudge, good to see you. How's it going? Welcome. All right. So I think I'm going to just pull this back up for a discussion, and then we're going to talk about how I'm thinking we're going to implement this. But we have ads that are going to start like any second now. because Twitch kind of gives me a warning. So I don't want to start explaining this and then have ads pop up. All right, there they are. So for those of you who are new to the stream, on the Twitch side, we are served ads once every 30 minutes for 90 seconds. There's not really any way of avoiding that, right? Because we don't want pre-rolls. And so what we do is we pause the stream so that nobody misses content. And that way, you know, we're not explaining something while, you know, the stream is sort of moved up into the corner into that little tiny window, and then you can't hear it, right? So it's a good opportunity for me to also get a little bit of water, right? So out of respect for our viewers, I like to pause the stream for that, right? And most people are pretty on board with that, I feel like. All right, so we've got about a little over 30 seconds left on ads. So we'll just wait on that, and then we will pick up where we left off. How are you guys over on the YouTube side? How are you guys doing tonight? Bear in mind, this is an interactive stream, so if you want to, you know, hop into the chat and say hello or ask a question, feel free. You know, I love chatting with you guys, so don't be afraid to come into chat and say something, you know? All right, ads are dead. So what we're going to take a look at tonight is generating this sort of skirt geometry. And we're going to generate this similar to the way that we generate the chunk geometry, right? So we're going to generate this in full resolution and then skip vertices based on the LOD that's been rendering, right? So let me actually... So in other words, this is probably going to look, you know, like this for the second LOD, third LOD, fourth LOD, and then fifth, right? Be really tiny, right? Obviously not to scale, right? But, and so what we're going to do is we're basically just going to have a single column or row, depending on orientation here, that goes all the way around, right? And that's basically how we're going to attempt to do that. And I'm thinking initially, at least, we're probably just going to have this go straight down. So if you look at one of these terrain chunks from the side, you might have something that looks like that, right? And then these skirts will come straight down. Oops. Relatively straight down, if I can draw it, right? Like that. And then, you know, it'll just kind of look like that. And we'll have basically rectangles that look like that. That's what I'm thinking. So it's basically going to be just a single row of additional vertices all the way around. And then we've got to figure out how to connect those in with these existing ones here. The other thing that we're going to have to bear in mind is the normals of this, or the normal calculation of this, which is going to get a little bit weird. Because what we do when we are loading this up is per chunk, right? We generate the vertex information, we generate the index information, and then we do generate normals and generate tangents on it so that our normal maps and stuff are correct, right? And this currently generates that for just that, you know, the top face, right? And so what I don't want to do is when we're generating normals and tangents, it does it based off of an average of the triangle points and the points around it, right? And so what I don't want to do is I don't want to take these into account when we're doing that, right? And so I think what I'm going to do is in our array, we're going to have basically our vertex data is going to be something like this, right? So here's the entire array, right? And then basically this whole section of the array is going to be our top surface data, right? It's going to be that. And then at the end of that array, I'm going to fill in the skirt data. And what that will allow me to do is it will allow me to say, okay, well, here is all of the vertex and index information up to that point. Generate this based off of that. And then from there, I can just go ahead and generate the index information and the vertex information here, not include it in that that calculation, and it shouldn't mess things up, right? So that's just kind of what I'm thinking there. Let's see. Smudge, you're over on the YouTube side too. Nice. Appreciate that. Doing good, thanks. Awesome. Doing good here. Glad to hear it. Let's see. Have I ever seen of any of Tom Mulgrew's work? He made a hybrid engine that uses polygons up close with a transition sparse voxel octree and set distance from the camera for LOD. I'm not saying you should do it, but I thought it was cool and you'd find it interesting. I'll tell you what I'll do. I will take down his name because I've not seen it, but I will take down his name and make a note of it. Let me see. I've got... Yeah, I'll put it in this one. Here we go. Okay. Work on it. Okay. I've made a note of it, so thank you for that, and I will definitely take a look at that, because there are... It's kind of one of the things that there's a billion different ways to handle it, right? So the way that we're handling it is kind of a simplistic way of handling it, and that's fine. But yeah. Okay, so what we're going to need to do, and I think the way that I'm going to handle this is, let's see, we have the vertex count. This is initialize. Okay, so here's where we calculate the vertex count and the index count, which are both going to need to be increased. So what I'm thinking is we probably are going to... We're probably going to keep two different counts. Essentially a total count and then a count for that top surface, right? And my first thought on this is to leave the vertex count as it is, and just use that as it is for right now. Maybe rename it to surface vertex count, and then we'll have maybe total vertex count. And then the same for our LODs. We'll have like a surface index count and then total index count is the way that I'm thinking of handling that. So let's rename this to surface vertex count. Of course, that didn't. Let me actually open that over here. All right, so our terrain. Let's do... Oh, wait a minute. This is in the... This is in the chunk. So surface vertex count. And then we'll also have like a U32 total vertex count. right? And we'll use that for like the size of the array. So total vertex count includes side skirts. So we'll do chunk total vertex count equals chunk surface vertex count plus, and then we need to take the out terrain chunk size. Right, so that's going to give us our rows and our columns. And then we have to do one per side, so that's times 4, right? So times 4 sides. So we just need a sort of one layer that goes all the way around the outside. And I'm thinking that's actually going to be chunk size plus 1 times 4. So that we don't mess that up, right? Because we have that extra row of vertices that we need in each dimension. All right. And so basically all we have to do is we can use these two numbers to figure out how to access that data to set it up. And then for each of the LODs, which is where we store our index data, oh, wait a minute. I almost missed this. Vertices needs to use the total vertex count. Right? And then here, the index count, we're again going to do a rename on this. So we're going to do surface index count. And again, the rename didn't catch over here for some reason. Oh yeah, it actually did. Okay, I don't know why it's saying it didn't, but it did. All right, and then so our LOD, you know what, I didn't add this. I need to add U32 total index count. Suppose I might as well add the comment while I'm here. The total index count, including those 4 side skirts. All right, and then this is going to be the index count for the chunk surface. All right. Let's see. So we have the surface index count, and then we'll say LOD total index count equals LOD surface index count plus, let's see, we have dimension. Which does make sense to reuse. Okay, so we can say dimension times 6. And that should be sufficient for that extra set that we have, I believe. Or is it dimension times 4 times 6? Yeah, it's got to be dimension times 4 times 6. Yes, okay. All right, and then instead of surface index count, it's total index count that's used there. Right, and by renaming this, we should... I think the only other place we're going to have to check that is probably in destroy. Probably have to check it everywhere just to be sure, but... so we're going to k-free... This needs to be total vertex count. This needs to be total index count. right. So what we're going to do is we're actually going to handle the creation of our surface data and our skirt data separately. So generate surface data. And then we'll do generation of skirt data. And then just to make sure that we don't miss anything down here. Okay, the extents can use the surface count -1, so that's good. Generate indices. This is going to be surface indices. Right. And then after that, generate skirt indices. This is where that's going to go. When we generate the normals and tangents, we want to do that against the surface vertex count and the surface index count. So that's all good to go. Let's see, terrain initialize. I don't think we need to do anything there. Terrain load. Okay, so this is where we create the geometry. This is going to be a little bit different. So when we create the geometry, we're going to do a surface vertex count. This needs to be total vertex count. And total index count. And then chunk LODs, we're just copying this over, so that needs to be total index count. Yeah, I think that makes sense. All right, let's see. So when we allocate from our buffers, we need to use the total index count on that. And then I think that's good for that. Unload. Destroying the geometry. We technically should go through the LODs and actually release that data too. I missed that actually. So if we have indices, first off, this free needs to use the total vertex counts. This free needs to use the total index counts. But before we do that, we need to do render buffer get, I think it was. Yeah. I think that's what it was called. Render buffer type index. We need to move this up. There. Render buffer index buffer. So we'll get the index buffer. And then here we will do render buffer free index buffer. And then we want this. And the offset is going to be the LOD index buffer offset. Right? So we free it out of the, we free it from the GPU as well, which we weren't doing before. So that's good that we actually caught that. That should be all we need to do there. And we're good. Okay, so now all we need to do is actually create the skirt geometry. Okay, Sleepy Mushroom, hello. How's it going? Good to see you. Orlin the Mage, thank you for the follow. I appreciate that. Let's see. Line 79 should be plus. Yep, you're right. I set that to equals. Good catch. Thank you. I must not have been pressing shift hard enough. Okay. Yeah, that would have been kind of a nasty bug, right? Doing a walking sim in OpenGL? That's awesome. I've always wanted to make one of those. Stretch redeem for 250. Appreciate that. By the way, since I have a decent number of people here, I want to give somebody a shout out because he's given me several shout outs. And he's a good dude. Let's see. How do I... Can I do that? There we go. Spiridon FL. He's been pretty supportive of this channel, and I like the work that he's doing, and I think he's still live right now, so I definitely want to give a shout out to him as well. He's good people, and his chat is really entertaining to watch at times, for sure. So just wanted to toss that out there and say thank you to him for all of the support. All right, so... Now what we need to do is generate that data. So I think probably what I'm going to do is iterate sides of this and then generate the data in the direction of that side is what makes the most sense to me. I'm just trying to think about a way that I can do this in like a reusable loop, right? Because I could theoretically just brute force it and just loop each side, but that seems kind of redundant and poopy. So I guess what I'm going to do is we'll say for U32 S equals 0, S is less than 4, plus S, right? So that's for each side. And then what are we going to consider our sides here? So I guess we could say, let's do left, top, right, bottom as our sides, right? For each side. My kitty suddenly wants lots of attention. Let me see if I can actually grab her, put her on camera. There she is. A free kitty redeem for you guys. She's full of purrs and she wanted attention, so figure I'll give her attention for a second. Show her on stream. Oh, Smudge, did you actually redeem that like the second I picked her up? That's funny. She really wanted to go and she was clawing the crap out of my arm, so I might pick her up and do a see if I can get a better. Let's see. There's a little bit better of an image of her. So this is Pumpkin. This is my 13-year-old kitty. She's a Japanese bobtail. And she generally doesn't like being held. I'm kind of the only one that gets away with it. And even that sometimes. But yeah, that's her. She has something to say, exactly, yeah. And that would be give me more treats, is basically what she's trying to say there. Lots and lots of treats. Perfect, exactly, yeah. Okay, so, I think what I'll do is, I think I actually am going to brute force this for right now, and then we'll like turn it into a reusable loop later, right? Once I map the logic out, get it working, then we'll take a look at it and say, okay, what can we extract from this and loop it side by side, right? So we'll do the left side first is what we'll think of. U32 I equals 0. I is less than chunk. Do I want to do... Actually, I want terrain chunk size. And then plus I. Right, and this is vertex data, so actually I'm going to need the chunk dimension, because I want chunk size +1. So, chunk dimension, right? And for this one, let's keep a running tab that we're going to call... I guess we'll call V, right? And that's going to be the index into the array. So V is going to start on chunk to surface vertex count. Right, so it'll start there. And then every time we iterate this, we're also going to increment V, so that we keep that moving. And then we can do, actually, do I want to call that, let's call that VI, right? Because I want to use V for terrain vertex, V equals address of chunk vertices sub VI rather. Right? And now we can set that stuff directly. So let's do... So we don't really care about the normal information, right? We can copy that as is. We can copy the color as is. We can copy the text coordinates as is. We can copy the X and Z positions as they are. The only thing that has to actually change is the Y. So what I'm thinking is this is our target vertex, right? We also need a source vertex. Right, so we'll call this terrain vertex source vertex, I guess. And that's going to be chunk vertices. And since we're doing the left side, we basically need the first vertex along the whole left side. So that's going to be I times chunk dimension, actually. And that'll give us that first vertex all the way down the x-axis. Right, okay, so basically we're going to copy everything from from SV to V and then modify V. So we'll just do a copy on this. Shoot, ads. Could have swore we just had an ad break. But for those of you who are new here, I just break the stream whenever ads come up on the Twitch side, which is every 30 minutes for 90 seconds. I'd like to just pause the stream, take a quick second to grab some water, and just let those ads clear out so that nobody misses any content, right? So we're about halfway through that ad break now. All right. Let me actually just check something while we're on ad break. Do I already have... Good Lord, I have far too many tabs open. I need to close some of these. So many tabs. All right, looks like ads are dead. So I'll check that thing that I was going to check later. All right, so we're going to copy the memory from SV to V. So do V, SV, size of terrain vertex, right? So we'll take a copy of that, and then we'll set v dot position dot y minus equals like 0.5. That might be entirely too much, but that's what I'm going to go with for right now. So that's the left. Right is basically going to be a modification of this. So let's do right next. Right. And that is going to be just a different source vertex, right? So in this case, we need I plus, or I times chunk dimension plus chunk dimension. No, it's going to be chunk dimension dot minus 1. I think we need to actually use the chunk size. So T chunk size to move us all the way over to the right side, right? So this will essentially get us the proper row, and then from there we move all the way over to the right. And everything else should be identical, right? So that's that. And then we'll do top next. Right, so top is going to be basically the same thing as left, but on the y-axis. In this case, our source vertex is actually just going to be I, right? Because we're just going to go along the top of it. Yeah, I guess it really is that simple. Okay, that feels too simple, actually. So the bottom is the last one, right? And this one is going to be, the source is going to be I plus terrain chunk size. Okay, so that is all the vertex information. We can take a look at that and obviously split that out and make it a lot cleaner. in a single loop. But for right now, I'm not going to worry about it. All right, let's see. Let me catch up on chat. Nako, yes, exactly, Smudge, yep. Hey, Magettes, how's it going? Your cat awakened you? It's 4 a.m. there? Jeez. My cat does that to me every once in a while. She likes to sleep on my hip sometimes when I'm, like, I'm a side sleeper, and sometimes she sleeps on my hip. It kind of wakes me up whenever she steps on me. Sometimes she steps on my lap, too, when I'm sleeping on my back, and that's not nice. She doesn't have the name Nutcracker for nothing. All right. So I'm going to leave that as it is for now and just verify that that's working, and then we can clean it up, right? Get it working first, then we'll clean it up. We need to generate the skirt indices next. And I'm going to do this similar to how we did the vertices. So we're going to do a U32, I guess we'll call this II, right? And we're going to say this is equal to LOD. Let's see, we'll use not total, surface index count. There we go. We'll start at that. And then for U32, we can use I again. I equals 0. I is less than. What did I do for this one? I think it was just... We did chunk dimension here. But that's not exactly going to work for what we need for indices. I think for indices it was... dimension. Times 4 times 6. Okay, I'm actually just going to grab all of this so I can reference it down here. Right, I'm not keeping this here, but let's see. So we're doing LODs here. So actually, I might wind up keeping this. So we have chunk size, chunk size. The dimension is here. Surface index count. We don't care about that. What we care about is the skirt count, right? So it's basically going to be just U32 skirt index count is equal to this. Get rid of the 4, right? So it's basically just dimension times 6. Right, and so skirt index count plus I. And we're also going to plus II so that we increment our position into the index array as we go. Okay, so again, we're going to do, what do we do? Left, right, top, bottom. So left, right, top, bottom. Okay. So, we need we don't actually have to copy information here, so we don't need like the whole source and target thing here. Essentially, all we need to do is set numbers in this case. So, we probably ought to follow suit of what we did in this loop and just do I plus equals 6. So I will be plus equals 6. And then we can just kind of do this thing again, right? So I'm going to grab this as an example, and we're going to tweak it. All right. So we don't do the row and column stuff here. So I have to think for a second how this is going to work. So we're going to need vertex, or the amount of tile width. So chunk size times 6 is what we're going to need to get the... Let me think about that for a second. So to get the appropriate index of... I think that makes sense. All right, so let's do U32, and we'll say I also have to ensure I get the winding order correct on this, right? Let's see. So if we start the triangle at, let's say, vertex 0, right? We'll do the first one as 0. So we'll say this looks like we have a different order commented here than what we have here, which is actually... I guess I could reuse some of this logic, right? So I is technically the row in this case, right? So I guess we could call this U32 row equals I. And then U32 call equals 0. That's always going to be 0. And then we have next row and the next column. But we actually have to do this backwards. So I don't think this is the way I want to do it. What debugger to use? Is there something better than terminal GDB? Yeah, I can't stand terminal GDB. I've used it before, but I'm not a fan. Basically, what I'm doing right now is I'm using this as my debugger, which essentially sits on top of that. But yeah, that's more or less what I'm doing, right? It's just using this guy. I don't use this to code in, but I use it to debug. Let's see. Howdy nerds, do you cache each LOD mesh after you generate it? So there actually is only ever one mesh. So all we do for LODs is we have all of our vertices, and then as we're rendering different LODs, we just use different sets of indices. And each LOD level skips an additional set of indices. So we just skip indices as we're rendering our terrain. That's how we do it. So the mesh never actually changes, it's just what parts of the mesh we render changes. You could use an index buffer with triangle strips, reset the index, so after each row of triangles, you'd have one reset index. Yes, I probably could and should do that at some point. And that would work great for this solution, but the problem is doing that would block me from doing the other solution if I ever wanted to do it, which would be sort of generating those patch triangles, right? Because that would get weird. So you're right, but I can't do it that way because of that. Triangle strips may be very expensive in some hardware. I've heard that. Yeah. I think mobile comes to mind on that, where it's not cheap to do it that way. So I'd have to like write in some detection for that. I mean, we do support that. We do have support written in here for that, but I just haven't used it. And also, hi, Psycode. How's it going? It's good to see you. All right. All right. This is just causing me to overthink it, so I'm not going to do that. I think what I'm going to do, let me think. So if we have, sometimes I have to map this stuff out visually to see it, right? So if we have our surface here, and this is a dumbed down version of it, right? And I essentially want to start here, go to here, go to here, and then start here, go to here, go to here. So I would have to start along, I'd need the row, the next row, but then column would always be 0. So essentially I'd want to do, it's going to be I times width times 6, which is what we already have. Which is this guy here. So if we do U32, we'll call this vertex 0. And this will equal I times skirt index count. Let's see, times, wait, no, that's for the whole row. Yes, so that'll give me a 0 based thing. And then if we do U32 V1 is going to be one row down from that, so it'll be I plus 1 times skirt index count. And then the next one is going to be our first vertex that we've generated for the skirts. So it's going to be U32 V2 is going to be chunk surface vertex count. And that's it, actually. And then U32 V3 is going to be chunk surface vertex count. Actually, this one needs to be +1. I'm thinking if it's, oops, to maintain that counterclockwise pattern. Right? So assuming this was the first vertex that we generated and this was the second. Oh wait, no, I did have it right the first time. I think. I might have that backwards. If our winding order is foobar, we'll know why. All right, so essentially what we're winding up here with is, let's see, this index should be V0, then V1, then V2. Then V1, V3, V2. Two, and then V1, V3, V2. I think that's right. All right, and then This is also going to have to be offset by I think. Right, so I think we have to offset this by II. Whoops. To keep that moving along. Which didn't we have? I thought we had that stored somewhere. I guess I could create another. No, I think that's good enough. I think that's gonna do it. All right, so that's left. Right is going to. Oh, wait a minute. This is skirt index count is for the entire dimension, right? Yeah. Okay, that should be good. All right, so if I do this and then do the right side, the difference here is going to be, this is going to have to be plus, I'm going to have to multiply these first. Make sure those get multiplied. And then move it over by chunk size to get to the right side of it. Chunk size. And then we should still be good with this because we're still incrementing this guy. Yeah, okay. I think... oh, also, this needs to be II all the way down. Because that's the section of the array that we're into, right? So this needs to be II, not I, or otherwise we'll just keep overwriting the same thing over and over again. Okay, so that's the right side. Top is going to be similar to left, except in the Y direction. CallMed, thank you for the follow. Appreciate that, and welcome. Love me some MS Paint diagrams. Yeah, exactly. Sometimes low tech works just fine, right? I have no issue with it. Okay, so in this case, we want... Oh, you know what? We might have to invert the winding order on this side. I'm going to test it first, but... I suspect that's going to have the faces facing the wrong way, so we can fix that later. Okay, so starting at the top, our index is just going to be I and I plus 1 for the first two. Then we're going to have... Oh, wait a minute. Actually, doesn't II already start off at surface vertex count? Yeah, we don't need this. It should just be that. Right. And that's going to be the same thing for this. Almost incremented too much there. All right, so that's that guy. And then this guy is going to wind up being II as well. I think that's going to be the same all the way down. because we're just moving along that same set of geometry. So that should be that for the top. The top should be simple. The bottom's going to be a little bit more complicated, but not much. So in this case, it's going to be I. We're going to have to I. Basically going to have to shift all the way down to the bottom. Did we do that correctly up here? I feel like this is wrong. But I'll come back to it. Because I don't think I offset that correctly, because now I'm thinking you have to actually offset by all the rows all the way down. Except for the last row. So this needs to be I plus T chunk size times T chunk size, oops, chunk size minus 1 to move to that last row. We need a plus in there, right? That's going to be the same. Winding again. Okay. So we've got that. The only other thing I think we're going to have to change is in the simple scene where we're querying for the data. Let's see, we have index count, which is now wrong. This needs to be total index count. And total index count. I think that's going to do it. We'll build and see how bad it crashes, right? All right, let's bring this down. And load. Yeah, that's not too surprising. All right, so let's see exactly what we're trying to do here. LOD indices. This is just generating the surface indices. Interesting. What? Okay, what kind of garbage data are we dealing with here? What kind of garbage data are we dealing with? So LOD. Let's take a look at the chunk memory. Can we even take a look at the chunk memory? Apparently not. Chunk offset Y and Z. Okay, that shouldn't matter. Okay, so this is one of the lower. Wait a minute. No, that looks correct. But the LOD information is completely foobar. All right, so why is that? Because it's like it's not even generated correctly at all. We have ads. So for those of you who are new here, on either side, on the Twitch side, we get ads served to us once every 30 minutes for 90 seconds. So I like to just pause the stream whenever that comes up so that nobody misses anything, right? So it kind of sucks on a programming stream to just have ads cover everything and you can't see anything and you can't hear anything, right? And then you miss stuff, and that's not cool. So that is kind of how we operate around these parts. How are you guys doing tonight, by the way? Hope everybody out there is doing well. Edge, exactly. Yep. Exactly. Gives me a chance to hydrate too, which is important, you know. So we've got about 13 seconds left on ads, and then we can crack on. Adjust my posture a little bit too. All right. Ads are dead, so we can continue. So what we're going to do is we're going to take a look at our logic here towards the top, where we're generating the arrays for these things and see if we can figure out what the heck is going on. I suspect it might be something having to do with this, but we'll see. All right, so let me put a breakpoint here, I guess. And we'll rerun the application. And I'll load. All right, so our LODs, when we start off, they're pretty much like zeroed out, right? In fact, let me kill some of this other stuff over here. So let's do chunk LODs, and I happen to know that there's 5. So these all start off as zeroed out memory, which is fine. Okay, so for this first one, we have a total index count of 1920. That has gone up because of our need to generate the skirt geometry. So the surface count is 1536. Yeah, that does make sense. Okay, so dimension is 16 times 4 times 6. Okay, yeah, so that makes sense. And then we go ahead and we allocate against that total index count. Right, and then we have that, and that's all zeroed out memory as well. And we just do this a bunch of times, right? So we can see our index count going down with each LOD. That makes sense. I still need to figure out why the last 2 LODs have the same index count. So I think this is wrong. Something about it is wrong anyway. Because that index count is way high. Well, actually, maybe it's not. But it shouldn't be the same for these last 2. Okay, so we've got that. And then if we go back down to initialize. Oh, this is for all the other chunks, right? So we go back down to initialize. All of these look normal on the way in. So we're going to actually skip the vertex generation and assume that that's correct. Yeah, none of that clobbered anything there. Let's see. All right, so wait, why do I have? I don't want a breakpoint there. Continue. All right. These things all look good. Oh, wait a minute. Oh, those aren't null. Okay, I just saw the 0 there and thought those were null, but they're not. Okay. So, we start off at the... This is generating the extra vertex data. Okay, so I don't think any of these are going to be a problem. So I'm actually going to skip all the way down to here, where we generate the index data. So we have to do this for each LOD. So we generate our surface indices. I'm going to skip past that. Right, we're on LOD 0. So I'll skip that. Okay. Let's see. So dimension, in this case, should equal 16. Yep. Let's see. Are you implementing kallocate as a global arena allocator? Yes. Yep, that's exactly what it is. It's just a big arena for right now. Eventually, with all the memory tags and stuff, I'm going to divvy up blocks of memory within that allocator so that I can put all like types of data together. But I haven't gotten there yet. But that's what the whole tagging thing is for. Yeah, tags can be useful for sure. They're also really good at, because I have allocation counting for each tag. And so I can check it every frame if I want to and see if there's anything that's, that's leaking. And I can say, oh, well, I've got a string leaking somewhere. And it kind of gives me a little bit of a hint as to where that might be. So it helps identify leaks too. More fine-grained control. Yep, exactly. And technically speaking, I could also use the tag to determine what alignment I need for different things, right? Because when I go to implement SIMD, right, if I go allocating memory for, I don't know, like a matrix or something, right? I can say, oh, this is a matrix that I'm allocating here. I need aligned memory for it. Versus I'm allocating a string, who cares what the alignment is? So, dimension times 6. Yep, so that makes sense. Skirt index count. Oh, wait a minute. This should probably just be dimension, not that, because we're actually taking the 6 into account there. That's probably the issue. All right, so instead of skirt index count, this should be dimension. And then the vertex this should probably also all be dimension. I think everywhere I'm using this should all be dimension, which makes me think that I might not even actually need the skirt index count. Liminox, thank you for the follow. Appreciate it. Welcome. First time chat. Watching your TypeScript game engine course. So good. Is this project in C? Yeah, that TypeScript project is old. I forget every once in a while that was actually a thing. But yeah, this is all completely written in C. I'm glad you're enjoying the TypeScript one, though. I might actually pick that up again at some point. because there were some things I wanted to do with that. But now that Web GPU is a thing, I might actually do that in favor of WebGL. We'll see. Rest assured, though, that that series eventually will make a comeback in some form or another. But yeah, it's still very much applicable to what you can do with it, right? You could still build on top of it and very much use it to make something, right? All right, let's run this now. And okay, we're loading. So we didn't immediately bomb out, but our geometry is borked, right? So that's pretty cool. So one of my calculations somewhere is definitely foobar, right? So what I'm going to do is I'm going to start off over off in this corner, right? Because this is where the corner of the terrain starts to generate, right? So that's going way off into the distance for some reason, which is making me wonder if it's actually using like valid data or if it's actually just like nans or something. So that's not what I expected. I mean, it's half what I expected, right? I wasn't thinking I'd get it right in the first shot. I almost never do. Okay. I mean, I at least got this corner vertex right, but it looks like the whole thing is just kind of... It's like it's shooting off into the distance for some reason. Oh, and that's cool too. So we've got an issue freeing memory somewhere as well. Okay. Yeah, it might be overflowing. Yeah, that's kind of what I'm thinking. Something along those lines, right? So I think I'm basically just going to get... I'm going to attempt to get one side of it correct first, and then we'll go from there. PKZ, thank you for following me. I appreciate that. Is it PK Zeno? PK Zeno? I'm not sure if I'm pronouncing that right. Yeah, it might be overflowing, reading no blights. Yeah, it definitely seems like something like that. Index ordering is probably foobar as well, for sure. You're almost done. Learned a lot of JavaScript things because of the course. Awesome. Glad to hear that. Glad to see that it's still useful, too. Because I made that a long time ago, so I wasn't sure if people were still following it or not. So that's really cool that it's useful. I write C in my day job, so I might jump on the C course next month. Maybe easier than the TypeScript one. If you're used to C, then probably, yeah. But then again, we dive into Vulkan here, so maybe not. Depends on what your graphics programming knowledge is, right? Okay, so let's re-review what we're doing, logically speaking. So, to generate the sides, we get the dimension, which is the number of vertices... No, the number of indices needed for a particular direction. Or is it the... No, it's the... Wait. Is J still the... Okay. It's not any of that stuff I just said. Scratch that. What it is it is the number of tiles across for the current LOD, right? So, number of tiles for the current LOD. Right, so LOD 0 would be 16 in our case, LOD 1 would be 8, 2 would be 4, 3 would be 2, and then 4 would be 1. So that's what the dimension is. And then as far as the skirt indices, we pack that onto the end of the array after all of our surface indices. So that starts at surface index count. I think that's correct as well. So that is good. I have no idea how to pronounce that, but I'm just going to say math. Thank you for the follow. I appreciate that and welcome. All right, so let's see, for dimension, for each tile for the given LOD, we're going to iterate each one of those, and we're going to have 6 indice places per each one of those, right? 6 indexes or indices per quad. So that makes sense. Our vertex 0 is going to be I times dimension, right? So that's going to give us the row. Wait a minute. Does that need to be +1? Let me think about this for a second. So the chunk dimension. Oh, I think that might be the problem. We need to be using the +1 size to actually iterate that stuff. That's what we're doing. That's actually not to iterate, but to grab our correct vertex index. So in other words, for here, instead of dimension, this needs to be chunk dimension. Right? Same thing for this guy. All right, let me build that and see what difference that makes. It's not going to totally fix it. I definitely know that. There's no question about it. I just want to see kind of where it lands after that. So this left side here is what we're mainly talking about. That actually does look a lot better, though. We at least have this edge correct if we look at it, right? That is connected in with where the terrain line is. So we've done that correctly. Okay. So what that tells me is that these are not right. Oh wait, why would I be using II for this? That doesn't actually make any sense. I would need to be using... I need a separate index offset in here. So U32 VI again, which should be starting at LOD, not LOD, chunk. Surface vertex count. Right, and then we should be using VI for this. And then as we iterate through this, we're basically going to be using, we're going to move forward 2 of these at a time. So vi plus equals 2. Wait, so no, it's not always going to be 2 either, is it? Because I've got to think about the current level of detail we're on as well. Which means that this is only going to be correct for the first level of detail. So we should be using should be I think I'm going to have to follow a similar pattern to what I did here. So this should probably be shifted by J. To get the correct offset there. And then the chunk dimension is literally just, is that right? So instead of plus equals 2, this needs to actually be plus equals 1 shifted by J as well. Okay, let's see if the, oh, you know what? The, I wonder if the vertex information could also be wrong. Let's build this and see. Wireframe could help, yeah. I could kind of see it like what I was, when I was looking at it before, I could kind of see what it was doing. Right, but the wireframe is also kind of a mess too, right? Oh, wait a minute though, hold on. This side over here is correct now. The winding order is wrong, but it's correct. See that? We do actually have it. Yeah, so I just have to reverse the winding order. Yeah. So that's not a big deal. Which is funny because I thought I had it backwards on the right side, and this is actually going to be correct. This is what's actually going to wind up being wrong. So the second triangle has the ordering wrong. I think they both do, actually. Freaker3, thank you for the follow. Appreciate that. Welcome. So what we really need to do is do 2, 0 there, and then swap 2 and 1 here. All right, and take a look at it. All right, so I can't see it from this side, which is hopeful, because I think that means it's going to be right this way. Yep. So now it's correct in that direction, which is awesome. So I could take that same information and use it to fix the right side. Because that's more or less going to be the same loop, just the winding order is going to be different. So actually, right, it's going to be that. And then I'm just going to copy pasta this down here, but I'm not going to replace it. Because I think I have to offset this I times chunk dimension plus T chunk size. I think that's still correct. And then this plus T chunk size. Oops. Wait, what happened here? Oh. Got an extra thinger there. All right. And then this should still be correct. So let's check and see if that is correct. All right. So all we need to do is find the essentially the right side of a chunk here, which actually it's right there. We can see it. That doesn't look 100% correct. That looks like it might be off. Yeah, it is. It's off by 1. Let's see. Yeah, I can see how it's all sort of leaning to the side there, so it's... I think it's going to be the first is off by 1. Really got to figure out what that memory issue is too. So I think it's going to be this guy that's off by 1. I wonder if I do need chunk dimension here. Chunk dimension. Let's see. Where is... that might not be right, because now I can't actually... Oh, wait, there it is, right there, I think. But it's really hard to see, unfortunately. So there's the end of the chunk right there. Has that actually made it worse? Or is our winding order wrong again? Ah, that's what it is. Our winding order is incorrect. But it does line up correctly. Okay. Alright, so again, it looks like it's going to be the same as this guy, which is not what I expected. Pesky winding, yeah, exactly. Oh, we got ads. So for any of you that are new to the stream, whenever we get served ads over on the Twitch side, we go ahead and we pause the stream, and that is once per 30 minutes for 90 seconds, just so that nobody misses any content while there's ads playing on the screen, right? So that's just kind of the way we do it around here so that you guys don't have to miss anything if you are sitting through ads. And I could also partake in much needed hydration. Let's see. So we're actually we're making pretty good progress on this. I think we're going to be able to wrap this up tonight, actually. We've got about 15 seconds left on ads. And then we can crack on. All right, and I think, yep, ads are dead. Cool. All right, so we've built. Let me go ahead and just check out this winding order here. Make sure that we're good to go. And then we'll fix one of the other sides. All right, so if we look this way, let's see, where is it? Did I forget to build? It's still backwards. I thought I built. Oh. That's probably what happened before. Program is still running. It's annoying that Windows does that, by the way. Linux does not lock the file, and it can be overwritten even while it's running, because it's in memory. Okay, let's try this again. All right. Am I missing something, or is this still... It's still backwards. Or am I looking at the left side of the next chunk over? You know what? I think that's what's happening. I think that's actually what I'm seeing. I'm seeing... Yeah, that's the left side of the next chunk over. The winding isn't backwards. It's just wrong. Yeah, I think it's the next one that we're seeing. All right, so let me think about this. So up here, we were able to do I times chunk dimension to get each row. So if we want the end of that row, instead of chunk dimension, yeah, we should need chunk size. Because chunk dimension is just chunk size plus 1. Right? Yes. So when we initially did this for our... We have row times that plus column. Oh, maybe it needs to be chunk size minus 1, actually. Instead of plus, maybe it just needs to be minus. Chunk size minus 1. Because theoretically, if our winding is correct on both sides, then when we're looking at a seam between two chunks, we should essentially be able to see the same geometry from both sides, essentially. Or very similar geometry. Let's see. Nope, that's still not right. Is it back further, maybe? Nope. Oh, wait a minute. It's going... I think that's it right there. It's going diagonally. Why has it done that? And has it... Sometimes I need to see it solidly too, you know? Trying to figure out what is... That's definitely the left side of that one, but where is the right side actually going? It's not very obvious. Maybe I should fix the top side first and come back. Because maybe that'll get some of that other garbage geometry out of the way. So we need to do... This is pretty much going to be the same thing wherever we go. So we can at least change to that. And then top is going to be very similar to left. So is this literally just minus the chunk dimension part? I think it is. Plus or minus winding. Yeah, I could just start with 4 vertices and add more just to see where it all goes bad. Yeah. Looks to me like the edges are moving 1 row on the end cap. Yeah, exactly. It looks like it's off by 1 somehow, and then it's like snapping to the opposite corner. Well, I see a lot less garbage around, so that's encouraging. All right, so let's see what we have over here on this edge. Hey, that's pretty close. Pretty dang close. Except for that one that shoots all the way over there. It's like it's overflowing or something. So it looks like the 4th point is the one that's wrong. Because this point is correct, this point's correct, that one looks correct too, but the one that's here is just wrong. Well, I should say the point is correct, the index is wrong. Because that one's like stretched off to the next one. So for the top, we just move along these guys. just along the top row. We don't have to offset anything. It's literally just I and then I plus whatever the LOD level tells us to move over. And then we have VI, which is sort of that moving vertex index that starts off at the surface vertex count. So it starts at the end of that array and moves forward. So this literally starts at after the last point of this, which is assuming this is correct. Assuming VI is actually incrementing correctly all the way down. It does for this one. So I have no reason to believe that it wouldn't do it correctly for the others. I don't think this is it, but also let me do this. If I was you, I'd probably do the easiest terrain rendering possible. Hierarchical clip map. That's a hard word to say. Clip map, yeah. Do, not did. Gotcha. Yeah, I can't say I disagree. Can't say I disagree at all. Okay. So if we are I'm still not convinced this is right either. Because we actually have, let me think about this for a second. So we actually have 17 vertices in one dimension, right? So for the first LOD, we are So for the first LOD, we're just moving one at a time. We take that one and the one next to it. This dimension. Oh, I think that, I'm thinking maybe this is what's wrapping around. Because we're doing dimension here, which is, well, that's going to be chunk size, which is 16, not 17. So the +1 should be valid there. So I don't think it's that, actually. Oh, but between here and here, we technically need to skip that. I think that might be what it is. We need to skip that last vertex, right? I'm thinking. I'm not 100% sure that's right. But it feels like we're not skipping a vertex that we should be. because we're only iterating up to dimension, which is going to be 16, right? And then we have that +1, and then the next vertex in line technically would be that 17th one, not the first one on the next row. Did I really misspell dimension? Ah, you're right. Thank you for that. Oh, what the heck, Vim? All right. There we go. I really need to put like a spell checker in here, I guess. The hierarchical clip map kind of reminds me of how to do 2D scrolling is implemented on the NES. The idea is kind of similar. Oh, your E key switch is dying? I hate when that happens. I've got a graveyard of keyboards with dead E keys. Hate that. Hate that a lot. But yeah, are you talking like the Mode 7 thing that they used to do on the NES? All right, let's switch to wireframe. Hey, that's promising. Look at that. So the question is, I think the winding might be backwards again, because I think I think what we're seeing is the inside of the top one. Yeah, but it is correct, right? So we just need to flip the winding on the top one. So this one needs to be this. And you know what? I'm going to run it again just to make sure that that side is also correct before I move on. All right, so go past all of this stuff. I probably should have just moved the camera, but now I'm almost done, so I don't really think it matters. All right, beautiful. So we have two sides figured out. Right, we've got that. All right, so now we need to figure out the right side, which doesn't look all that far off, I don't think. Actually, looking at this, it looks like it's just connecting in a row back from what it should be. Because you can kind of see that incline that's happening there underneath this one. So I think this is just an offset of one that's just off. So the right side, maybe we don't need this -1. Maybe that's what's foobar in that. Move the camera or slightly increase the translation speed, yeah. Eventually, I'm going to build that stuff into the console so I can just like control it from there. I just haven't done it yet. It's one of those things where it's like, I haven't done it because I'm lazy about it, but like the laziness is costing me time too. It's kind of a power struggle there. All right. All right, we can see it from this side, so I think we're actually good. I think we're good on that one. Yep, now we can see that from both sides. Sweet. Making bacon. All right, so now all we have to do is figure out the bottom half, and then we have to figure out this dingus memory issue as well. Whatever's going on there. All right, so I can get rid of this. Don't need that. So the bottom is going to be similar to the right. So I'm going to take this. Actually, I'm just going to take the whole dang thing. Go to the bottom. And pasta that right in there. And then I'm actually going to go up here and remove this because I know that that is the correct winding order for it. And these comments half the time aren't correct, so I'm going to remove those as well. Let's clean those up. Right? And then here, we just need to get this correct. So this is going to wind up being I was thinking chunk size times chunk size minus 1 plus I. So here we have chunk dimension, which gives us the rows. And then times chunk size. Can't be that easy. That just seems way, way too easy. And I doubt that's going to work, but it'll probably get us close. In the hierarchical clip map, you have to... Wait, you have a large plane mesh that has at most 3 vertex density in the middle. Wait. Has the most vertex density in the middle. Yes, okay. In the vertex shader, the vertex movement is actually implied with fractional camera coordinate, and the relative coordinate is used for the sampling of a height map. Interesting. So it's... okay. So essentially you're not creating the geometry that way, you're doing it in the shader, essentially, is what I'm getting from that. Let's see. Aren't clip maps a pretty old technique? I think so, yeah. If that's doing what I'm thinking it's doing. Okay, awesome, yeah. Yeah, I would check out a video on that, because if it's doing what I think it's doing, then yeah, it's kind of an old school technique. Let's see, Cole Voss. Hey, just started going through the Game Engine playlist to learn C better. It's good. Thank you for the great content. I appreciate the feedback on that. Thank you very much. And welcome to the stream. I always appreciate the feedback you guys give me. Means a lot that it's valuable to you guys. And of course, you know, if you guys find something in it that's not ideal or something that something I missed, feel free to always call it out, right? I appreciate that too. All right, well, obviously I did not get the bottom side right. That's painfully obvious from how this looks. Okay. So, what do we have? Are we even close? Does not look like it. Okay. All right. So let me think about this. So before... We don't need the... Oh, wait a minute. We don't want to start all the way to the right with the chunk dimension. That's wrong. This should just be... This should be I plus chunk dimension times chunk size. Right, because this chunk dimension times chunk size should get us to the last row. And then this should be a plus as well. Times chunk size. What did I get wrong with the... Oh, we have extra Oh wait, I need this one back. There, okay. So yeah, I think that's right. Winding order might still be backwards. We'll see. Thee are forgiven, thou shalt not worry. That's funny. Sorry for the E key. It either types nothing or double. That's why the. I thought you were getting biblical on me for a second. Super funny. Okay, that looks better. I don't know that we've completely solved it yet, but it's better. All right, so let's see. What do we have? Are we off by one again? Let's see. I need to look at this side here. So the bottom side is going to be... Where is that separation? Where are those lines going? You know what? Let me go over here. Let's go to a little bit more of a clearly separated one. All right, so we've got that. And the boundary of it is right there. So from this side, we don't see anything. Oh, okay. I think that's the same issue again. So we've got a little bit of an incline there. So I think we're off by one row again. But it looks like it's off by... Actually, it looks like it might be off by 2 rows. Okay. So maybe this needs to be chunk dimension. It doesn't make a hell of a lot of sense, though. Because if it was a chunk dimension by chunk dimension, that's going to put us at the bottom right corner of the map. Well, I built it. Let me at least look. Great for Old English. That's fantastic. I love it. Broken keyboards and the amusement that ensues. Okay, so... Is this the... Let me go back over here. Let's look at this one. It's a little easier to discern what is going on. All right, so... oh, wait a minute. It still looks like we have... We've still got a rogue vertex here somewhere. Okay. Yeah, something's still not right with that. And I don't know if it's that last row or not. Okay. But if we take a look at... Where's the... So here's the bound right here. Yeah, it's still off by 1. Okay. Oh, we have ads. So let's see. I will get to the YouTube comments as soon as the ads are done. So, for those of you guys who are new to the stream on either side, we break once every 30 minutes for 90 seconds, because that's how often we're served Twitch ads. So I like to make sure that nobody misses anything. While we are broken for ads, if you haven't already, I would ask that you consider subscribing on the YouTube side and following on the Twitch side, because those things help me out a lot. And definitely, spread the word about the channel, right? I'm trying to grow both channels, really. So any help that I can get there, I greatly appreciate it, right? Hoping to reach more people, for sure. Little Sparrow 31, thank you for the follow. I appreciate that. All right, we got about 20 seconds left on ads. And then we can move on. All right, and ads are dead. Cool, so we're back. So I think this bottom one here is the last one that we really have to figure out. Although I suspect, after having looked a little closer, we might have a rogue vertex or two going on with these other guys, but... okay, so let me think about this for a second. So our chunk dimension essentially right now is 17. So what we need to do is we need to navigate to the 17th row of vertices to use for our first two vertex points. So in order to get to the 17th row, we have to have 17 wide and 16 tall. So this might have to be terrain chunk size, which I thought is what I had before, but I also then switched some of this stuff out, so I'm not 100% sure about that. And then these two should iterate like, or increment like they always do. So maybe it was just that. Let us see. Let us see if I can draw a terrain correctly for thee. All right. Well, that looks like it's completely... Actually, it looks like the whole thing is off by an entire row. So this is the start of the next chunk over here. But the bottom row vertices is aligned to the chunk after that, and I think the top row is aligned to like the next row's chunk, which is not right. So we need to shift this bottom row of vertices up by 1 and the top row of vertices down by 1, because I think it's wrapping. It's an iteration count thing. Yeah, exactly. It's definitely something in here is just wrong. So these two are off by 1. So I'm wondering if I really do need to do this. Which I had that in there at one point, but it was used differently, so I'm wondering if that's it. Okay, all right, that's better, right? So we fixed the row of new vertices, I think. No, we haven't. How did that literally adjust nothing? How was that possible? I don't think these are wrong. I wonder if the vertex data is wrong. In theory, it shouldn't be, right? But maybe it is. Because I wasn't sure about this, right? Like maybe it's the vertex data that's wrong. So for the bottom row, the source vertex is... How the hell could this be true? This would need to be I plus... trunk dimension times trunk size. To move it all the way down to the bottom. Could all come down to the vertex data, yeah. It's highly possible that that's wrong too. And I'm pretty sure that the bottom at least was wrong. Oh, that already looks a lot cleaner. That already looks a lot cleaner. All right, so let me see what we've got. Is that okay? Not quite what I had in mind. It looks like it basically just created... What is it, off by one? Yeah. It's off by a row. The top. The top is off by one. So this line right here should be snapped against this, is what I'm seeing. Because if we did that, right? Yeah. So let me think, what would cause that? So now I'm thinking this is actually correct. So now I'm thinking it's actually back to a indexing issue, which I'm thinking maybe this was actually correct without the -1. Any chance that rogue vertex thingy is screwing up things? It's possible. Yeah. It's highly possible. We're getting pretty dang close though, right? Okay, so where is the... Where is it? It's just gone. Oh, that's right. I had some comments over here on the YouTube side. Sorry about that. Love how this is looking. Thank you. Appreciate that. Can I ask how you're rendering the ground plane? Are you just drawing lines in 3D? Yep, that's all it is. Yeah, it's literally just drawing a bunch of lines. You're talking about this grid thing? Yeah, it's literally just a bunch of lines. And then what I did for the origin points is on the x-axis. I did red for the origin along that, and then green for Y and blue for Z, which you can't really see from here, but it's in there. Yeah. So that's basically what we did for that. Let's see. See, now I'm not seeing that rogue vertex that we were seeing before. I'm not seeing that at all. But I'm also not seeing, like, the bottom edge at all. It's just gone. So when I had this, it was just off by 1 row. But I removed that and it's like completely gone. Does it need to be? Wait a minute. I don't want -1. This should be using the last row. Hold on. This should be using the last row. Wagers on whether or not this fixes it. Okay, it didn't fix it, but it kind of created a kick-ass pattern under here. That's kind of a neat effect, huh? That's neat. Okay, so why did it do that? Did it wrap around? Nope, I think I was right before. It should just be this. So if we say we want 17 units per row, times chunk size, is that going to give us the 17th row or the 17th column? Maybe that's the issue. This might be a column issue, not a... So this is I plus... So the I plus is correct. I think it's this part that's wrong. So if we do 17 by 16, assuming that they all go like this, that should give us what we want. I'm trying to think of any reason why it wouldn't give us what we want. Oh, wait a minute. Did we... Wait a minute, we might have... No, we handle all of that first. And then we tack this onto it. That's nice. I just got here, so I'm out of context. So yeah, basically what we're trying to do is we're building essentially skirts around all of our terrain chunks that extend straight down. And we're doing that to fill gaps in the geometry between levels of detail on different chunks. And we've got 3 of the 4 sides figured out, but the 4th side is giving me a little bit of trouble because it's I've got like my looping for creating the data is wrong, and I'm not sure whether it's index data or vertex data that's wrong. The other 3 sides seem fine, but this one, not so much. See, I mean, it looks fine like this, right? But like when you go under here, we should be seeing basically this little bit of geometry extending down. We should see that on all sides of each chunk. And we have 3 of the 4 sides figured out, right? So there's the other side, right? So we have all of that. The side that we're missing is sort of the, the south side of it, right? So we have, that's sort of you could think of that as, I guess, the north side. And then this would be the south side. And the south side is just not showing up, right? I'm trying to figure out why that is. And what's really bizarre is the offset that I'm thinking it should be is just causing it to like not render. And I don't see any rogue geometry here whatsoever. So I'm really not sure. Not sure what to think at this point. Looks like our level of detail is wrong, but it's probably only on that one side that's wrong. Actually, that might give us a hint. So why would that be going all the way over there? I don't think this is a winding issue because we would just see it backwards if it was. This seems correct to me. Let's see. Is it the last side that is handled? Yeah. Yeah, it is. And if I counted for like the extra vertex in each dimension along the way. But yeah, it's the last side that's handled, which is making me think of maybe it's just like overflowing the actual index array. Which actually I suppose is a valid point. So actually, that might be exactly what it is. That might be exactly what it is. So the surface index count is dimension times 6. So that's basically how many tiles we have in a chunk times 6. Our total index count is that plus our dimension, which is going to be our sort of side skirts, right? So for each one of those, we have four of the side skirts, right? And for each one of those tiles, we have 6 indices. So I guess just to make this a little bit clearer, right, we could just swap those two, right? So we have a single dimension times 6, right? So that's tiles in one direction times 6. And then we have 4 sets of that. Should be enough. Right, we have the surface index count here. We do that plus this. That should be enough for everything. I guess what I could do... Let me build this real quick. And I'll throw a breakpoint. I'll throw a breakpoint in there for when we get to this last bit. Let me see, where is this? So line 330. Oh, if I was in the right dingus file. All right, so when we go to generate this guy, all right, so we'll load this up and then see. So we have our, oh, I don't have chunk down here anywhere. I'm gonna have to scroll and find it. Okay, so our chunk LODs, which were gonna be in the first one. Let's see, so we have a total index count of 1920, right? The surface is 1536, then we have 1920. And so our VI our current index is 1824. Let me go over here. Actually, I have it right here. So we have room in the array for it. We're not at the end of the array yet. So chunk dimension 17, this should be 16. And our I is 0, so that should be 272 in terms of vertex. Should be 272 and 273, essentially, yeah. So those should be along the bottom edge of the chunk. And then we have 340 and probably 341, which is the bottom edge of the skirt. Let me make sure those aren't out of bounds too, actually. So our terrain, what is it, terrain? Oh wait, no, it's chunk. Is it G or GO? Oh, I haven't saved it off yet. Okay. Let's do chunk vertex counts. Total vertex count, rather. So 357. And we are at 341. 16. Yeah, okay, so that seems correct. That's like the correct place in the array. Each iteration of this, we bump up the position in the index array by 6. It's the exact same way as all the other ones. It's counting vertices or edges. So we're counting vertices, technically. We're going edge by edge. Now, eventually, like, we have a lot of repeated code here, right? So we're eventually going to clean this up and merge those loops. But while I'm still trying to figure it out, I separated them just to make it a little easier to debug. So now I'm thinking, this is giving us the correct vertex index. And this looks correct too. Because technically speaking, let's see if this has already been written too. Oops. LOD. No. So that index has not been written to. That one has. That one has not. So let's see. Dimension is 16. Let's put a conditional breakpoint here and we'll say I is greater than. Actually, I'll just say I equals 15. Run the rest of the way through. Oh, did I just step over that like a dumbass? I think I did. Damn it. Does the last vertex need to be counted as the first? Does the last vertex need to be counted as the first? No, why would we have to do that? It doesn't wrap around if that's what you're asking. So basically what we do is we do the left, then we do the right, then we do the top, then we do the bottom. Okay, so if we step into, why is that? So 15 is less than dimension, right? Let's step into that. See, I'm stepping into and it's like stepping over it. I don't understand. Do I need to move this down? All right, you know what? Let's put the conditional breakpoint here and we'll say I equals 15. Oh shoot, add break, I missed it. Well, we're already a third through it, so I don't think I'm going to pause the stream this time around. I think I'm just going to keep working. So 287. Well, that's a problem. That's an issue. Oh, wait, no, it's not. I thought it was, but my brain tricked me with the numbers here. Dyslexia is a bitch. Trips me up all the time. So 287, that's still well within... Let's do surface vertex count. 289. Right, and this is 287 and 288. This is the last iteration of this guy, too. Oh, wait, no, that's correct. Yeah. 288 would be, index 288 would be the last vertex on the surface. So these are correct, then. We are getting those correct. And then V2 is 355 and 356. So these are the last two vertices on the surface. These are the last two vertices on the skirt geometry. So that all should be correct. FV7, thank you so much for the tier 1. I appreciate that. Thank you for the support. It's the Thor hype train song. Yeah, I really appreciate the support. Appreciate that. What am I missing here? Are we just not drawing it for some reason? Because I don't see it anywhere else. Total index count. QueryByte, thank you for the follow. Appreciate that. Welcome. Total index count. 1920. Okay. And we're at 1914. So that's 15, 16, 17, 18, 19. So all of this stuff lines up. This data here looks correct to me. Which must mean that somewhere in, perhaps over here in Simple Scene, when we are querying the render data, maybe we're not doing it correctly somewhere. So let's see. Use the indices for the current LOD. Total index count. We're doing that there. Total index count is here too. Ooh. Vertex count. It's using the geometry vertex count, which is not correct. That's the problem, I think. This probably shouldn't be using the geometry at all. It should probably be using the chunk LODs, chunk current LOD. Oh wait, no, this is at the top chunk level, actually. We want total vertex count. And chunk Vertex. Do we not store the offset? I guess we don't. Okay, we'll have to use the geometry one for that. I wonder if that's what it is. Total vertex count. Because the weird thing is like, I think we have the data lined up, but it's just not drawing it. I may have to render doc this to actually get to the bottom of it. But let's try this one more time. Yeah, I think we've still got some issues here. So where is the, okay, there's the boundary right there. So that is the north side of the previous chunk. South side just doesn't render. Let me turn on regular rendering mode. Right, like we should be able to see that from this side too, and it just isn't anywhere to be found. The lower LODs though are like blasting out polys this way though, which is really suspect. So I wonder, probably I'm gonna have to increase the camera speed to be honest. Is any part of the other end rendering? Do you mean like all the way at the other end of the terrain? That's what I'm going to look at now. Because I'm wondering if there's something down here that's just completely screwy. And it looks like there might be, because I'm seeing geometry pieces like pop in and out. There's huge long things that are popping there. So yeah, like you can see these over there, those look completely wrong. And actually, check out the elevation difference too. So that's suspect for sure. Because this almost looks like the elevation from the other side of the map. It's exactly what it looks like to me. And I wonder if the same thing is true all the way at the south end of the map. Yeah, it's very suspect for sure. You think it's trying to seam with the other side? Yeah, I'm kind of wondering that too now. And that might actually be my vertex data that's doing that wrong, come to think of it. That's exactly what it looks like it's doing though. Oh, we got a whole bunch of garbage down here, it looks like. Yeah, look at that. That's definitely not right. And once again, we're missing an entire row here. The right side has it, but the bottom side doesn't have it. And then this just kind of goes over here and falls off a cliff. So I think it's like it's wrapping around somehow, which is really bizarre, and I'm not 100% sure how or why it's doing that, because it's literally just a straight array of vertices, right? I don't keep them in a two-dimensional array or anything like that. So how that's wrapping around back to the other side, I can't quite wrap my head around. But what I am seeing, and this is extremely sus, is this is 100% flat all the way across? I think not. It should be following that up there. Why is it flat? Well, I was hoping we would finish this tonight, and we got a pretty decently far along the way, but unfortunately, I have to get up and work in the morning, so, yeah, I've already kind of gone over by like a half an hour, so, I'm probably going to have to call it quits for tonight, on this at least, and find somebody to raid, just because, yeah, sleep is a thing, right? So what I'm going to do is, this does run. It does crash when you shut it down, but it does run. So I'm going to check this in as a work in progress. So at least it's up on the repo so you guys can access it. So we'll do work in progress, terrain. I guess we'll call this terrain skirt geometry. And at least that way, it'll be available for you guys on the terrain chunk branch on the repo. Yeah, and I think that's part of the other problem I'm having is like I'm getting tired, right? So I think my brain is just telling me I need to go to sleep. So let me see. Let me see who's online. You know what? I think for tonight I'm actually going to raid Ferret Software again, because I like to do that at least once a week if I can. So if you're not familiar with who Ferret Software is, they are it's a ferret rescue, and it's essentially a 24/7 stream that runs, and the ad revenue for it funds the ferret rescue. And I think it's a really good cause. All of the ad revenue, everything for it just goes straight towards that, and I like to support it whenever I can. So join just in time for the raid. Yeah, I hate when that happens. I hate to have to do it, but yeah, I think that's what we're gonna have to do. So let's go ahead and start that. And I thank you guys for joining me here on stream, and over on the YouTube side, I appreciate you guys as well. Let me drop a link on that side over there, so that you guys over on the YouTube side can access it if you want to. And yeah, if you haven't already, I encourage you guys to follow me both on Twitch and on YouTube if you haven't already, just so you don't miss the next time I go live. So anyways, thank you guys so much for the support. I appreciate it, and I will see you guys in the next one. Peace.